Hello, so today we are going to solve this problem called Spiral Matrix 2. It's part of Leetcode April Daily Challenge. So the problem says that we get a positive integer n and we want to generate an n by n matrix filled with elements from 1 to n squared in spiral order. So like this. So we need to go in spiral order and then we need to just put the elements. So first I will just initialize a list here. So that would be put 0 and then in range of n, and then we'd have to do this for n by n basically, and then we need to have our value, right? So maybe counter here, and so we want to start from, let's see, we want to start from 1, okay? So that would mean here we need to have 1, and while it's smaller than n by n, equal here, less than or equal. We know we want to do counter plus 1. And we know that what should be our I, right, index. So we want to maintain our x and y values, I and j values, so let's call these 0 and 0, or maybe let's call them x and y. And since we are doing a spiral order, we want to have directions, so first we know that we want to go, in the, from left to right, so column increases, which means 0, we need to add 1 to the column. After that, we go from, we increase the row, right, for column, so increase the row, so that's 1, 0. We add 1 to the row, so that's why in this position. After that, we want to go right to left, so we want to decrease column, so that would mean 0 minus 1. And after that, we want to go down up, so we want to decrease the row, which means minus 1, 0. Okay, so those are the directions. And what we want here is to say x and y is going to be equal to counter, and 0, 0 is going to be equal to counter. Now, after that, our direction starts out at 0, right? So dx and dy is going to be equal to directions of position D, okay? And our next x and the next y are going to be x plus the increase, right? Now what about when we want to change direction is if we are outside of the boundaries, so this would be rows, sorry, this would be n, and this would be nx, the new position. And same thing with ny. Now here we just want x and y to be the next one. Otherwise, we want to go to the other direction, which in this case, for example, is to go from the first row to the last column direction, which means here we want to say d is equal to d plus 1, and we want modulo 4 so that we can go back to, so for example, if I do here, so for 8 and 9, that's when direction reaches 4, and we're going to go back to the same direction as the first one. So that's why we need modulo 4 here. What else? And then at the end we want to return res. Let's see if this works. So yeah, it doesn't work. There is a problem with this. There are spots that were not filled. That's the problem. So can I just do res, and then here just append instead. Append what I want to append is counter. Oh, that's problematic. It won't. We want equal. The values are actually no. These are indices, so it should be in that. Yeah, the problem is here. I didn't update the value, so xy now is going to be equal to dx and y plus. So this is d0, or let me do x dx dy here is going to be equal to that direction, and then this will be dx, and this is dy. So sometimes we may get out of range here with this. Let's see why. So it's just 0, 0. It seems like it's. Oh yeah, I deleted that. Sorry. So this would need to be that. Okay, my output is completely messed up. So for 0, 0. We go back to 0, 0, which is not what we want. So I will do scene here, which is set, and here I will add the position that we already. Okay, and then here and an x and y not. Let's see. Okay, so that looks like it worked. Let's try a couple of other examples. Maybe 10 to 11, 15, 30, 40, for example. Oh, so at most 20. Let's try 20. Okay, looks like that worked. Let's submit the solution. Okay, cool. So that passes test cases. Cool. I think one way we can improve the solution is get rid of this extra space that scene is taken. So when the result value is not 0, we know that we've already seen it. So we can replace this with res x and x and y bigger than 0. So only if it's equal to 0 that we accept it, otherwise we turn to the next direction because we know it was already filled, right? So if we can run this, I don't need scene here. Okay, and that passes. Another thing I can simplify here is just put these in the same line. And our counter is going to be 1. Cool. Okay, yeah, I think so. This is good. It's all then squared, which it has to be because we want to fill each position, and we have to have extra space because we want to return a matrix. So basically, time complexity is O squared, which it has to be, and similar thing for space complexity. Okay, we can do better than that. Yeah. Yeah, so that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.